Welcome back everyone to this lecture on text methods with pandas. Often text data needs to be cleaned or manipulated for processing. For example, you could have a column that is a bunch of email addresses. So you have something like someone's name at gmail.com. And what could be a common task is to try to separate the domain names from the actual name on the email address. Now we could do that with our own custom apply function, but Pandas comes with many built-in string method calls. As you know, on any normal Python string, there's a list of method calls you can call, such as .upper or .split, and those sort of things are actually built in to the .str method call library in Pandas. So what we're going to do is we're really going to learn just how to use these and then leave it up to you if you want to reference the documentation for the giant list of all the various methods you can call. But what we're focusing on here is just how to run these using the .str library, as well as a couple of special parameters you can call within something like a split method that would really only apply to a pandas situation. Okay, let's head to the notebook and show you what this is all about. Okay, here I am in the Jupyter notebook. As a quick note, if you check out the 07-text methods notebook, I went ahead and put a link of the actual text data guide. As you can imagine, there's lots of method calls here, so I would encourage you, if you ever start working with text data and are looking for a specific method call you can do, just go ahead and check out the documentation. Here's the link right here, or you just Google search pandas user guide text, and it should take you to this working with text data page, and it has a list of string methods, as well as lots of really nice examples. A quick note, right now, in the form of pandas we're working with, as well as anything previous to pandas 1.0, there was the object data type, which was the main way that pandas stored text data. And everything we learned here is going to work on that sort of object data type. But into the future, what pandas is going to focus on is actually setting things to be a string D type. And it's just to clarify that everything in the column is for sure a string. Prior to pandas 1.0, this object data type with NumPy, it could technically store a mixture of strings and non-strings, which could down the line cause errors if you're trying to perform a string method call on something that's not really a string. So just keep that in mind. If you're reading data right now, it'll say it's an object, and for our cases, we can just treat it as a string. But into the future, with future versions of pandas, they're going to try to improve on this by just specifying if everything is a string in that column, then it's a string data type. Okay. With that being said, you can scroll down here, read about the behavior differences, but if you go to string methods section in this user guide, there's a bunch of string method calls you can do. And essentially, all these string method calls are built into a Python string object to begin with. So let me show you what I mean by that, and then we'll show you how to use this with a pandas series or on a data frame. So we'll come back here. As you know, if I have a string, let's call it my name, I'm going to put just lowercase Jose. In fact, let's actually make this an email. We'll say Jose@email.com. And then you know that I can say email dot, and then in Jupyter, after I've defined email, I can hit tab and see that this string has all these method calls available. And so what's nice about these method calls is they're actually built into pandas in the string method calls library. So I could do something like split at, and returns back this list split on the at symbol, where I can get the names and then domains, as I was just discussing earlier. So let's see what we can do with pandas, and the first thing I'm going to do is actually just create, let's say, a list of names, PD series, and let's type in some names. We'll just go with some ABC, Andrew, let's say Bobo, Claire, and David. And also what I'll do is I'm just going to put in let's say a number 5 there, because for some reason we had a placeholder since we didn't have a name. We just input the number 5. But you should notice that it's actually the string, not a just number. So we see names here, and we see it's a data type object because of the pandas version we're working with here. And then what we can do here is actually call methods on this. So if I really wanted to, I could say names.str.upper, run that, and it uppercases everything. Keep in mind, this does not permanently affect the series. We'd have to reassign it to make that effect permanent. But what's nice is there's lots of useful method calls on a string. And one of the most useful ones is actually just checking to see if everything is what you would expect a string to look like, especially since we're dealing with the object data type. So if I come back here to this email, I can say email dot, and you'll notice if I scroll down here, there are these is method calls that actually checks if something is a number or a digit, etc. So I can say something like is digit off a normal Python string, and you'll notice it's false. But if I do have a digit or something that could be a digit like 5, and I say is digit on this, you'll notice it returns true. So as you may expect, if I come back to names, hit .str dot, and if you want you can hit tab here, and it will show you that very similar list of method calls that we saw here. Essentially, all those method calls you can call on a normal Python string, you can call with pandas, and it's going to attempt to call that on every single string in that series or that column. So then we say names.str, we can say is digit, and then we get back the booleans but as a series. And so then, as we know, we can actually use this to filter by only grabbing where it is a digit, or only grabbing where it's not a digit, etc. So now you can clearly see how you can use these simple .str calls to start filtering out strings based off some sort of condition. So that's the very basics of the str library here, and you can always check out the documentation to just get a list of all the available string methods. But if you're familiar with Python strings in general, pretty much all those methods on a normal Python string are available to you here as a method call. But what I want to show you now is that you can actually split, grab what you want, and expand the series into a data frame. So to show you this example, I'm going to make a new object called Tech Finance. And this is actually going to be a list of just 2 items. Let's imagine we read in some data of some tech stock tickers. So I'm going to have the ticker for Alphabet, and then note where my comma is going. It's actually going inside the string. And then we'll have the stock ticker for Apple, and then Amazon. So for some reason, the way I read in this data, maybe I'm using some sort of stock API to read this, it grabs these and inserts them all as a string, but they are separated by a comma here. And then I tell it to, maybe on the second item, using this API, it grabs some finance stocks. So let's go ahead with, let's say JP Morgan, Bank of America, and then say Goldman Sachs. All right, so again, note what's happening here is if I check the length of Tech Finance, there's only 2 items in it. There's this string of Google, Apple, Amazon, and the string of JP Morgan, Bank of America, and Goldman Sachs tickers. So let's see what happens if I say tickers is equal to PD series, and then call Tech Finance on this. So I see my tickers, and I have just a single series here of 2 items, this guy and then this guy. But realistically, probably the way I want to organize this is to split this on the commas. So that way I can know I have Google separated from Apple, separated from Amazon. So if I just call str.split, and I want to split on the commas, now I have what is essentially here this string or list-like object, and what I can also do is then just grab items off of this. So for example, if I were to show you this, sometimes it's easier to understand if you just look at a single item at a time. So let's say tech is equal to this string. What I could do is say tech split on this comma, and now I have this list of items. And then what I could do is grab the very first item to get Google right here. Okay, so I can actually perform this sort of indexing with another call from str. So then I can say .str 0. So notice this kind of weird indexing call, but the reason it looks like this is because it's trying to show you the pandas equivalent for doing something like this over here in this cell, bottom right here, where we're saying 0. So if I run this, it will only return back the first items after the split, Google and JPM. Okay, so again, what's happening here is this is essentially in cell 184, the pandas version of running what's here in cell 183 on a single string. So very similar, except you're just calling .str before all these calls. Now here is where pandas is really powerful. Let's say we don't want just the first item, but instead I want to make this into 3 columns. And I can do that because they all happen to have the same amount of items, which is kind of a precursor here. So what I can do is, as a second argument inside of this split method call, I say expand equal to true, and what it does is it's going to expand this list to just be different columns. So we run that out, and then I can see here the first column is Google JPN, and essentially now I've built out a data frame. Again, that's using split, comma, and then expanding it out. Okay, so you can see examples of that again in the documentation. If you come here to string methods, you can start scrolling around, and eventually you actually see this sort of strip calls, lower calls, and you keep going down. It'll show you this sort of expanding true to get back a data frame. Okay, so lots of different things we can do here, but again, they're all based on what we already know about Python strings. The last thing I want to show you is just a quick example of stacking string calls, which is really common when you're doing this sort of thing. So let's go ahead and say, create a new variable called messy names. It's going to be a Pandas series, and what we're going to do here is just pass in a list of names, but there's going to be something wrong with each of them. So I'm going to type in Andrew, but then add an extra 2 spaces. And then on the second one, I'm going to type in Bobo, but there's accidentally a semicolon, or colon, doesn't matter, between BO and BO. So again, that's another problem. And then we'll say space, 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 Claire, space, space, space. Okay, so I have these messy names, and if I check this series out, I have Andrew, Bobo, Claire, and you notice that the spacing looks a little weird on Bobo, but that's because Andrew and Claire themselves have spacing. So it's a little hard to see here because we don't actually get to see where the white space is on this, but keep in mind that if we were to grab one of these, for example, the first item, we get Andrew and we see that there's spacing involved. So what we want to do is clean this up. Let's go ahead and first deal with the most glaring error, which is the fact that there's a semicolon inside of this Bobo string. So we'll say names, and then what I'm going to do here is say str, and I can simply call the replace method. The replace method just takes in as a first string what you actually want to replace, and the second string is what you want to replace it with. So in this case it says grab all the semicolons and replace it with an empty string, which means if I run that, I should get back Bobo, since it went through every single string, look to see if there was a semicolon, and essentially removed it by replacing it with nothing. And then what I can also do is use .str.strip, which is a way of just stripping out white space on both sides. So you can run this, and now notice how the formatting has changed, and if I grab 0 here now, Andrew is now fixed and no longer has that trailing white space. Again, that's the strip call, same call you would use on a normal Python string. So we run that, we have Andrew, Bobo, Claire, and then finally what we can do is capitalize this, which just means capitalize or uppercase the first letter. So we say .str, capitalize, and now I have my cleaned names. So what's really common with Pandas is to stack a lot of these str calls, and it makes your code pretty clean, and it's also pretty readable. You can see that you're replacing the semicolons, stripping out white space, and then capitalizing. And you can always check out the either normal Python documentation or the Pandas documentation to get a quick refresher on what method calls you're looking for. Always keep in mind that if you have something that's really hard to do, you can use an apply custom call. So I'm just going to copy and paste this from the lecture notebook. But as a quick note, we can see here that if I call this function cleanup and it does the same thing kind of one by one, then I could always take messy names and just say apply this cleanup function, and it performs the exact same thing since these are all string method calls. Again, it's kind of up to you whether you prefer doing something like this or something like the note above with the str calls. Keep in mind, if your stuff is getting really complicated and you have to start looking for certain situations like an if statement, after a while it's going to be impossible to just do it through string method calls, and you will have to create your own custom function. Again, it's really up to you which method calls you prefer. Some people don't even bother with this str library and just always do their custom apply functions, so in the future they can quickly edit it. Some people always try their best to use what's built into Pandas. Again, totally up to you. And the last thing I want to note here, and I'm going to bring in the lecture notebook for this, is at the very bottom we have a discussion on which method is more efficient. Is it more efficient to actually use your own custom apply call, or is it more efficient to use something like str replace str strip? And if you check out our results here, I used time it to actually time this code. Everything had the same setup. Keep in mind, for part of this, we had to define a function, but even with the same setup on all of them, if you look at the pandas string method calls, they actually perform a little slower in this case than applying your custom function. And if you decide to vectorize that function to make it work on a NumPy array, then it actually performs a lot faster. However, your data frames have to be quite large for you to start actually experiencing some sort of efficiency here. So if it's faster for you to type out the pandas string method calls, your time as a developer is more valuable than the computer's time to just crunch these numbers and apply these method calls. So it's always a trade-off here between your time and the computer's time and what's more efficient. And you always have to think, is this really worth it trying to squeeze every last ounce of efficiency if I'm just dealing with what is not a very large data frame? Again, questions I can't really answer because they're on a case-by-case basis, but we do have this efficiency cell so you can experiment with stuff and see what performs faster. Okay, thanks, and I'll see you at the next lecture.